Honda may have just given Aston Martin the most dangerous weapon on the Formula One grid. A reported 40 horsepower breakthrough could transform acceleration, straight-line speed, overtaking, and even the way Aston Martin designs its entire car. But the shocking part is not the number. It is what Honda may have changed behind that number, because if this power can be delivered reliably, without creating extra heat, weight, or tire problems, Aston Martin would gain something far more valuable than speed. It would gain freedom, and one hidden detail could decide whether this engine becomes a championship weapon or the most expensive trap Aston Martin has ever built. Subscribe to the channel. To understand why this reported 40 horsepower gain matters, forget the headline for a moment. Think about what Aston Martin is actually trying to build. Not just a faster car. Not just a machine that looks competitive for one weekend. A complete Formula One package capable of fighting at the front, under pressure, across an entire season. And that is where Honda's reported engine development becomes so important. Because Formula One performance is never created by one part working alone. The engine affects the cooling system. The cooling system affects the shape of the bodywork. The bodywork affects the airflow. The airflow affects the grip. And the grip affects how confidently the driver can attack every corner. One change can spread through the entire car. That is why 40 horsepower cannot be treated as a simple increase in speed. Imagine two Formula One cars leaving the same corner. Both drivers pressed the throttle at almost the same moment. Both cars have similar grip. For the first few meters, the difference may be difficult to notice. Then one car begins to pull forward. A small gap appears. That gap grows as the cars continue accelerating. By the braking zone, one driver may be close enough to attack, while the other is forced to defend. That is how a power advantage can change a race. But this is where the first major warning appears. The source reports a gain of around 40 horsepower, but it does not explain how the number was measured. It does not identify the comparison point. It does not reveal whether the performance can be sustained throughout a complete race. And it does not show whether the figure represents pure engine power, electrical performance, improved efficiency, or several developments working together. Those missing details matter. Because maximum power and usable power are not the same thing. A Formula One driver does not need an impressive number for one perfect moment. The driver needs predictable acceleration every time the throttle is pressed. The power must arrive smoothly. It must not overwhelm the rear tires. It must remain available as temperatures rise. And it must survive repeated use lap after lap. Think of it like a runner who can produce one explosive sprint. For a few seconds, the speed looks extraordinary, but a Grand Prix is not one sprint. It is a long series of accelerations, braking zones, temperature changes, and moments of pressure. The strongest burst means very little if it cannot be repeated. And this is exactly why Honda's reported development could become either Aston Martin's greatest advantage or its most complicated problem. More power creates opportunity. It can improve acceleration. It can help on long straights. It can give a driver a better chance to overtake. It can also provide engineers with more freedom when choosing how much aerodynamic grip the car should carry. But more power can also create heat. Heat requires cooling. Cooling needs space. And space can change the shape of the car. That sounds like a small engineering problem. It is not. The outside of a Formula One car is designed to guide air with extreme precision. Every opening has a purpose. Every surface influences what happens behind it. If the team needs larger cooling areas, the airflow may become less efficient. The engine may become safer, but the car may lose speed somewhere else. That is the hidden trade Aston Martin must avoid. Honda can create the power. Aston Martin must protect that power without damaging the rest of the car. And that challenge becomes even greater when expectations rise. The moment fans hear 40 horsepower, they imagine dramatic acceleration. They imagine overtakes. They imagine Aston Martin suddenly challenging the strongest teams. But Formula One does not reward headlines. It rewards balance. A car can be powerful and still struggle through corners. It can be fast in qualifying and damage its tires during the race. It can produce an excellent lap in cool conditions, then lose performance when the temperature increases. One strength cannot hide every weakness. This is why the real value of Honda's reported gain may not be the power itself. It may be the choices that power gives Aston Martin. extra performance could allow the team to use aerodynamic settings that create more cornering grip, even if those settings produce additional resistance on the straights. Normally, that resistance costs speed. A stronger power unit could help recover part of that loss. In simple terms, Aston Martin might be able to gain more grip without suffering the same straight-line penalty. And that could influence much more than one lap. More grip can help the driver carry speed through corners. Better cornering performance can change tire behavior. Tire behavior can change strategy. Strategy can decide whether a driver controls the race, attacks from behind, or becomes trapped in traffic. One engine development can create a chain reaction across the entire weekend. But the chain can move in the opposite direction. More power can create more heat. More heat can demand more cooling. More cooling can weaken the airflow. Weaker airflow can reduce grip. Reduced grip can increase tire wear. And suddenly, the advantage begins disappearing through other parts of the car. That is why the reported 40 horsepower figure is only the beginning of the story. The true question is whether Honda has found that performance without creating an equally large cost. If the answer is yes, Aston Martin may have more than a stronger engine. It may have the foundation for a completely different kind of car. But if the answer is no, the team could spend valuable time controlling a strength that was supposed to set it free. And the next part of this story reveals why the relationship between Honda and Aston Martin could decide which version becomes reality. That relationship is where the real pressure begins. Honda can build an engine with enormous potential. Aston Martin can build a car around that engine. But unless both sides make the right decisions together, the reported 40 horsepower gain may never become the advantage people expect. Because an engine does not simply arrive and transform a team. It has to fit. It has to breathe. It has to stay cool. It has to deliver power in a way the driver can actually control. And every one of those demands affects the rest of the car. This is why a closer partnership can be so powerful. Instead of treating the engine as a separate object, Honda and Aston Martin can approach the project as one complete machine. The power unit can influence the chassis. The chassis can influence the cooling layout. The cooling layout can influence the bodywork. And the bodywork can influence how efficiently the car moves through the air. When those pieces are planned together, the team gains options. But when one part changes late, the entire project can become more difficult. Imagine building a house where the walls are finished before anyone decides where the plumbing should go. The pipes may still fit, but every solution becomes more complicated. Walls need to move. Floors need to be opened. Space disappears. Time is lost. A Formula One car faces the same kind of problem, only at a far more extreme level. Every centimeter matters. Every opening matters. Every kilogram matters. And every compromise can cost performance. That is why Honda's reported gain is only as valuable as Aston Martin's ability to design around it. If the engine needs more cooling, the car may need larger openings. If it requires different packaging, the internal layout may have to change. If the power arrives too aggressively, the rear tires may become harder to control. If electrical support is not delivered smoothly, the driver may feel the car lose strength at the worst possible moment. The source does not explain whether Honda has solved those problems. It only presents the reported 40 horsepower development. And that missing detail is exactly what makes the next phase so important. Because the number creates expectation. But integration creates results. Aston Martin does not need the most impressive engine headline. It needs an engine that works with the car. An engine that allows the bodywork to remain efficient. An engine that can operate without forcing the team into excessive cooling. An engine that gives the driver confidence rather than surprise. And an engine that can repeat its performance when the pressure is highest. That is where the partnership will be tested. Not when everything is perfect. Not in one isolated measurement. Not when the car is running alone under controlled conditions. The true test comes when the track is hot. The fuel load is heavy. The tires are beginning to wear. Another car is close behind. And the driver needs every part of the machine to respond immediately. In that moment, the engine cannot simply be powerful. It has to be predictable. That word matters more than it sounds. Predictable power allows the driver to attack. It allows the driver to press the throttle earlier. It allows the rear tires to build grip instead of suddenly losing it. And it allows the driver to focus on the battle rather than worrying about how the car will react. A car that feels unpredictable creates hesitation. And hesitation costs time. Sometimes only a fraction of a second. But in Formula One, that fraction can decide whether a driver completes an overtake or remains trapped behind another car. It can decide whether the car reaches clean air or stays in traffic. It can decide whether the tires remain under control or begin to overheat. So, the real value of Honda's reported engine development may be hidden in the way the power is delivered. Not just how much power exists, but when it arrives, how smoothly it arrives, and whether it remains available when the driver needs it most. That is the first major question Aston Martin must answer. But there is another one. Can the team protect the engine without weakening the car? More performance can create more heat. More heat can demand more cooling. And cooling can become one of the most expensive compromises on the entire machine. A larger opening may help the engine survive, but it can also disturb the airflow. A safer temperature may protect reliability, but it may cost aerodynamic efficiency. And a car that loses too much efficiency can give away the very advantage the engine was supposed to create. This is where the project becomes a balancing act. Honda may want protection. Aston Martin may want the tightest bodywork possible. The engine engineers may want more airflow through the car. The aerodynamic engineers may want less disturbance around the car. Both sides are chasing speed, but they may not always agree on how to find it. That tension is normal. It exists inside every serious Formula One project. But the reported 40 horsepower figure makes the stakes much higher. Because nobody wants to be responsible for limiting such a major potential advantage. If Honda delivers the power, Aston Martin must prove the car can use it. If Aston Martin creates an efficient chassis, Honda must prove the engine can survive inside it. Neither side can succeed alone, and neither side can hide if the complete package fails. That is why this partnership could become Aston Martin's greatest opportunity. It is also why it could become one of the most demanding projects the team has ever faced. The closer both sides work, the more precisely they can shape the car around the engine. They can consider weight distribution, cooling requirements, internal space, energy delivery, and the way the driver experiences the power. Those choices can be made together. But greater control also creates greater responsibility. When the entire project is built around one shared vision, there are fewer excuses. If the car is slow, the problem belongs to the complete package. If reliability suffers, the consequences affect everyone. If the engine performs brilliantly, but the chassis cannot use it, the headline becomes frustration. And if the chassis is strong, but the power unit forces too many compromises, the promise begins to disappear. This is the part most people miss. A major engine gain can raise performance, but it can also expose every weakness around it. A car that was already struggling with traction may struggle even more. A cooling system already close to its limit may become vulnerable. A difficult rear end may become harder for the driver to manage. Power does not hide every problem. Sometimes it makes those problems easier to see. That is why Aston Martin must do more than celebrate the reported number. The team must ask whether the entire car is ready for it. Can the tires handle the delivery? Can the gearbox manage the load? Can the cooling system protect the engine? Can the bodywork remain efficient? Can the driver use the performance without losing confidence? Every answer must be yes. Not once. Repeatedly. Across different circuits,